Oh, she just texted me and said, are you still good? Oh, that's you. Never mind.
Yeah, that was me. Okay. So I guess we'll go to part 2.
Okay.
So the graduate admissions test is used for admissions criteria in many Masters of Business programs. The scores on the GMAT in the past have been scores of 529. The BYU professor feels now that the score has improved within the last couple of years. Determine the null and alternative hypothesis.
Okay. So the null would be it's equal to 529.
Yeah.
And the alternative would be that it's improved, so it's greater than?
Yeah.
529.
Yeah, that's what I'd say too.
Okay.
Let me see if I can open up my notes real quick. Okay, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. What type was a type 1 or a type 2 error committed?
So when the null is right, but then we reject it, that's a type 1.
Yes, type 1.
Is that right?
Yep, that's right.
Okay.
If the analysis was done that alpha is 0.01 level, what is the probability of committing a type 1 error? It's really low, right?
So it's like 1%.
Yeah, the lower you get, the lower there's a type 1 error, but the lower you get, the higher there's a type 2 error, I think is what they said.
Right.
So it would be low. Yeah, like 1%. If you wanted to decrease the probability of making a type 2 error, would you need to increase or decrease the level of significance? You would want to increase it.
Right. Is that, look at that answer on that one. Yep.
Did you look at the answers?
Yeah, it's increase.
Increase. Okay. Next, assuming that the natural standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchased the investor property and obtained the data shown. Design a study. What is the population from which the realtor obtained his data? How did he sample his population? What is the research question?
Okay, what is the population? Study home sales.
Different.
So the second home sales, people that are buying homes?
Yeah. People that are buying homes.
So, and he got it from the National Association of Realtors? Is that where he got the?
It says, I think he got them from his own clients, his client who purchased.
Okay. So then how did he sample his population? Randomly. Huh?
I think he selected his sample randomly.
Samples?
Yeah, from his own clients.
Okay, and what is the research question? He wants to know if the average age of those buying investment properties is different than the national average. So he wants to know if the average age is different. Not lower or higher, but just different.
Yeah, right.
Okay.
Okay. B, collect the data. Name at least one way the realtor could have randomly selected his sample.
Well, there's that app that you can do, but I guess that doesn't work. Just cut them up and put them in a hat.
Yeah, just draw them out of a hat. That sounds good to me.
Okay.
Describe the data. Graph the data on a histogram. Sketch the histogram below or cut and paste your electronic copy. In a short paragraph, describe the data by using at least 5 descriptive statistics. They
Oh,
basically want us to put all of it in SPSS. It looks like all those numbers.
okay.
SPSS.
So do you just put them all the way down 1 through whatever?
Yeah, I think so.
Okay, and to change so it doesn't have the little thingies on it, you do view
Variable view.
variable view, and you go 0 decimals. Okay, a second. My dog just ran out. Hey, hey, come here, Reggie. Hey, come here. Okay, sorry.
You're good.
We let her out, and I heard her out there barking at kids going to school. It's kind of bad.
Yeah.
Okay. So then we do that, and then from that we can just go to Analyze, Descriptive, Explore,
Yep.
and then all right. So we need 5 numbers.
So you just need the. That's in. That should be in.
Descriptive.
Yeah, descriptive.
Okay, just a second. Okay, so we need the mean.
Yep. The standard deviation. The minimum. Q1 median. Q3 maximum.
So which 5 ones do we need? Are we doing the 5 number thing, or are we just doing the standard deviation, mean? You know which ones?
Yeah, I think I'm not sure. In the answers it says that they just posted the mean, standard deviation,
Oh, okay.
and all that.
Variance, minimum, and Q1.
Yeah.
Okay. Are you got to that point yet?
Yeah. I've got mine posted. Okay, so then it says make inferences.
Standard deviation 8.827, minimum 27, Q1 variance 77.924. Q1 is, where's the Q1? Where's my Q1?
It should be in your descriptive statistics.
Median variance, median, minimum, range, quartile.
Where is Q1? How do you get Q1 again?
I think you have to.
You have to do it in percentiles, don't you?
I think so.
I remember we had to do that. So I think you go to
and put percentiles.
yeah.
Let's see.
Analyze, descriptive,
Yeah.
explore.
Well, let's see. It would be variable n percent 15.
Yeah, so then your percentiles would be your 25th percentile would be your Q1.
So it would be 43. Is that what 25th is?
I got 38. Let's see.
Oh, mine says turkey legs. I'm doing a different one.
Mine says turkey legs too.
Okay, wait a minute. It shouldn't say turkey legs because maybe that's just
A number.
I don't know.
And see their Q1 is 41.5.
Okay, I'm gonna try it one more time.
Oh yeah, that's right. Turkeys, hinges, houses. Yeah, that's the quartiles at the bottom. I think that's right. 41.5.
Okay, so now I did it again and I got what you got is 38.
And then below there should be turkey hinges. Did you get that?
So why are we doing that one?
I don't know.
Is that what the answer says?
That's what the answer says. It says it's 41.5.
Okay, well that might be an important thing to know, to do the bottom one instead of the top one.
Yeah.
Okay, and then let's see, and then do a histogram, but can we just look at the one we just made?
Yeah. Right.
Okay.
Okay, so D is check the requirement. Since there is only 15 pieces of data, what will you need to check?
Okay, it said on the answers, because I looked at this already, the
QQ. Well, that makes sense. Because that'll tell you if it's normally distributed.
So how do we do that again?
Analyze descriptive statistics, I think, and then QQ plots is at the bottom.
I don't remember that, but I guess I'll see what it says. And then once you put that into the variable, do you do anything different? Just put,
and then it'll give you like all the dots.
Oh, that's what the qplot is the line. Okay, got it. And so it looks fine.
Yeah, but there's two. Did you get two qplots?
Yeah, but it seemed like there always is a weird one on the bottom, but the top one's
the top one's right. Yeah, so it's good. State the null and alternative hypothesis.
Okay, so the null is HOU is equal to 47.
National, the national means.
And then HAU, and we want to know if it's different, so it's the equal sign with a cross through it.
Yeah, not. And so that's a two-sided tail.
Right.
So when we're trying to solve that one, we put it on each end.
Okay.
Okay, let the significance of alpha be 0.5. Compute the test statistic. What is the formula to be used? Z-score.
Right. Right. So Z equals X, which is, wait a minute, we get it. Okay, what am I thinking? We have to get the score. So 47. Oh, we have no, the only number we have is the mean.
Right.
We have an X, so
46.7. That's what I'm trying to figure out too. Because we have a standard deviation, that's fine. We have a sample size, that's fine.
the sample size. Okay,
15.
What?
The sample size is 15 because we have 15 numbers.
Right. Okay, so what we're missing then, do we use the mean that we got from, oh yeah, we use the mean that we got, the 46.73.
And what do we subtract it from, the 47?
46.73 minus 47 divided by?
Or is it 47 minus 46.7?
Okay, X is the number that we got, and then 47 is the mean.
Oh, okay.
And then we divide it by our standard deviation, which we got is 8.8. Should we just do it that, or should we go 8.27?
8.827.
Okay. And then divide that by the square root of, how many people are there?
There are 15.
15.
So did you get 0.209?
No. Let me make sure what I did wrong. 8.82.
I didn't get that. I didn't get that either, but that's what this answer is.
So it's asking us to do. Okay, but I got a negative
Right.
1184. Do we just have to plug that into our probability app? Is that what you're asking for? Is that the number?
I think this is just the z-score.
Oh, okay.
Test statistic will be the z-score.
Oh, so what did we do wrong?
I don't know.
Okay, so the formula is
The sample mean minus the regular mean.
so our sample mean is what we got, unless that's the wrong sample mean we got, but is that what it says on the thing?
It doesn't actually say what the numbers are. It only says the z-value is 0.209. Which our sample mean should be, yeah. Isn't our sample mean what our regular mean is?
46.73 is what they have on the answers, and then the standard deviation is 8.827. Okay, well.
So
4.673 minus 47 divided by 8.827 divided by the square root of 15.
Maybe we have to, I don't know. Let's see.
15. Oh, it says assuming the standard deviation was 5.
Oh, yes, that's true.
Or assuming the standard deviation is 5. So we need to do it with the standard deviation being 5. We don't use the other ones.
Okay, so
46.
I think it's 47 minus 46 point.
Why would it be that? Because isn't what? Oh.
Because 47 is the number that we're testing, but the mean.
Oh, yeah, that's our mean.
Yeah.
46.73 is the mean that we have as a statistics, and 47 is the number we're testing. Okay, you're right. And then we're doing 5 instead of 8.8.
Right.
Okay, let's see if that works.
And I'm still getting 2.32 is what I got. And they say it's 2.9.
47. Did you try doing it the other way with the other number first?
Yeah, it was a negative number.
Oh.
Maybe I'm just rounding it too much. 46.
Okay, I got 0.209.
Oh, you did?
Yeah, is that what it's supposed to be?
That is what it's supposed to be.
Okay. So I want 47 minus 46.73 divided by 5 divided by the square root of 15.
Okay, I got it now. I got it too.
Okay.
Cool. Okay, so that's the z-score is 209. Compute the p-value. First sketch the standard normal curve, graph your test statistics along this path, shade the appropriate area. So we pull out the probability applet, and because it's a two-sided, we shade the tails, and then we put in our z-score.
209 and negative 209. So it's like 83.
Yeah, 83. That'd be 83%.
Okay.
Okay. Compare the p-value to the level of significance. Do we reject the null hypothesis or fail to? So the significance was
05.
0.05, and our p-value is 0.8, so we fail to reject the null, right?
Right.
State your conclusion in terms of the alternative hypothesis.
All right. You say something like, we don't have significant evidence to fail it. Is that how you say it?
Yeah, insufficient evidence.
So you say there was insufficient evidence, or?
Yeah, something of the sort. It says we have insufficient evidence to conclude that the mean age of people buying a second home is different in this area than the national average of 47.
We have significant evidence that the mean is different.
What action, if any, do you suggest the realtor take based on your statistical conclusions? I would say he does the same thing. He doesn't change.
Okay. So if we fail to reject the significant, the null hypothesis, that means 47 is still the mean?
Yeah, so he should still be doing exactly what he's doing. He shouldn't change the age of the people he's targeting, I guess.
Okay, so why does it say on the conclusion we have, oh, insufficient. Okay, I read it wrong. Insufficient. Okay, that I was like confused. Okay, and take action, then no change.
Yeah.
Okay.
Okay, so we can open up the quiz. I need to plug my laptop in. Okay. Completed individual prep. Actually participate in group meeting. Sure.
Okay.
The hypothesis
test consists of two hypotheses, a null and the alternative. Represents the status quo, the null.
Right.
Okay. What hypothesis includes equality, the null?
Right.
The p-value is the probability of obtaining a sample statistic at least as extreme or one that is actually observed. When computing this probability, which hypothesis do you assume to be true?
The null.
Right. Suppose the null is equal to 10. Which of the following represents an alternative for two-tailed?
The third one with a cross through the equal sign.
Which of the following represents the alternative hypothesis for left-sided? The first
Top
one?
Yeah. So I always imagine the tail is whichever one's pointing towards the mean.
Right. Which of the following represents the alternative hypothesis for a right? Would be the second one.
Yeah.
The outcome of a hypothesis test is determined by comparing the p-values to the level of significance, or A. Use this information. Which relationship would result in failing to reject the null hypothesis? If the p-value is greater than A, less than A.
Greater than, isn't it? If you fail to reject, you fail to reject, so it'd be less than A. Right?
Okay. Failing to reject. So that means
you're not going to reject the null.
Okay, wait a minute. That doesn't. If we're not going to reject it, okay. If we're not going to reject it, that means it's closer together. It's not out on in the wings, right?
Right.
And if it's closer together, the p-value is going to be higher than the.
Right.
So which one would it be?
Because in this one,
greater than makes me confused.
So in this one, in the one that we did for our group prep, it was greater than the alpha, so
right.
We failed to reject.
Okay, so that means greater than that sign does?
Yeah. So the first one.
Okay.
If the p-value is greater than A, yeah.
Okay, all right. I had the second one, and I'm like, I don't think. Sometimes I get that less than and greater than's messed up, but if it's greater than, it always is pointing towards it.
Yeah.
Gosh, I don't know why that's so confusing. I had a
the
really
alligator eats the bigger value. That's what they taught us in middle school.
I know, and I learned something really crazy that was confusing, so I'm always confused. Which relationship will result in rejecting would
The
be
null.
the other
Would
one.
be-
So it would be
yeah.
less than.
P-value is less than alpha, yeah. An insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim amount was $1,500. They're concerned that the true mean is actually higher than this. Use the information to answer 11 to 12. Which of the following would be an appropriate alternative hypothesis?
Actually higher, so greater than.
Is greater than, yeah.
Okay.
Which of the following would be an appropriate null hypothesis? The average claim amount is equal to 1,005.
Yeah.
The insurance company randomly selects 40 and calculates a sample mean of 1,650. If the insurance company assumes the distribution of sample mean is normal, is that a good assumption?
Because there's 40, I guess.
Yeah, so it is because it's 40.
Okay.
It's going to be normal. What theorem or law justifies your answer? Central limit theorem.
Right. Which following is the test statistic as defined in this lesson? The top one, X with the bar over it?
Yes. Yes.
The historical mean of sales receipts at a grocery store is $150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following. That's equal and that's decreased. She will use the level of significance as 0.05. She takes a simple random sample of 36 and computes that the mean sample is 144. What is the z-score? So we go 144 minus 150.
Yeah.
Okay, divided by the random sample is 36, and what is where is the standard deviation?
A standard deviation of $40.
40, okay. 40 divided by the square root of 36.
She
36.
takes, 36.
So we put the numbers right? 44 minus 50, because 50 is always the
Is our mean, yeah. Yeah, it should be. And that's X with a bar over it, so that's the sample statistic.
Okay. Okay, and so we're trying to get the z-score, and I get negative 0.9.
Me too.
Okay.
What is the p-value associated with the z-score from the previous question? So we're testing this is the left wing, right?
Oh, that's right. What is
So we
this?
only shade the left side.
Okay.
So I think it would be 0.184.
Okay.
What inference would you make about the null hypothesis for this problem?
You'd reject it. You would fail to reject it
Yeah, fail to reject.
because it's not low enough.
It's not null enough, yeah. There are two types of errors that can be made when performing hypothesis, which involves rejecting the null when the null is true.
Type 1.
Yeah. Null is true, you reject it, type 1. A researcher decides that instead of using a level of significance of A.5, uses A. Which of the following will be true? The type 1 error will decrease.
So neither of those are right. Oh,
So the probability of a type 2 error will increase.
right.
Because when type 1 goes down, type 2 goes up.
Okay.
If A is 0.05, compute the probability of committing a type 1 error.
Okay, so do you do 5% or do you do 20%? Because I remember seeing somewhere on our stuff that 0.05 was 20%, but then when we just did it earlier and it was 0.01, that was 1%. So
Yeah.
I
Let me
saw
look in the
that.
book. I'll open up my book real quick.
Because it seems like it said that exact thing in our lesson this week, that a 0.05 equals to 20%, but it would make more sense have it be 5, but
0.05. This is equal to 1/20th. So there is a 1 in 20 chance that we will reject, which is 5%, right?
5%.
Okay. 1 divided by 20.
That's why I was confused, because it said 20, but 1/20th is still 5%. Okay.
So do you put 5 or do you put 0.05?
Do you just like put 5%?
I don't know.
Possibility? Do you type 0.05 into the?
I think so. I think that's what you do.
Okay, so if we put 0.05, it's not negative, right?
No.
And then what do we shade? I'm confused. I think it's
just 0.05.
I do too. I don't think we use that applet.
No, I don't think so. I think it's just a 5% probability of committing a type 1 error.
So 0.05 and 5%, I mean, should we put 5% or should we put 0.05?
I think 0.05.
So if it's 5%, we'll miss it, but whatever.
Yeah.
But it's the same thing, so it shouldn't be.
Right.
Should one of us put 0.05 and one 5%?
It doesn't matter. Just whatever you want to do. Okay. Should we submit it?
Yep.
Should we go over it again?
I don't know. And that's one thing on my test. I went over the test and there was 2 that I just totally read wrong and I would have got wrong. So yeah, go back over it because it seems easy, but go back over it.
Okay.
Individual prep, yes. Null hypothesis.
Hypothesis consists of 2, the null and the alternative. Which one is status quo? That's the null.
Null.
Which hypothesis involves equal? Null.
Computing assumed to be true is the null.
Yep.
Right?
Yep, right. Which is a two-tailed? I'm looking at the book right now.
Equal. Yep. Left-tailed is lesser than, right-tailed is greater than. Rejecting is when the p-value is greater than A, and failing to reject is
greater than A.
Greater than A, and rejecting is the p-value is less than A.
Right. And the average claim is greater than 1,500 because they suspect it's greater than.
Right.
Appropriate null.
Equal to.
Yep. It should be normal because n is 40.
Okay.
Central limit theorem.
Central limit theorem. That's the statistics little emoji thing. And negative 0.9. We both got that.
Yeah. 0.1. Fail to reject.
I put 0.184. Is that what you put, right?
Yeah. Yeah. It says round to 3 decimals.
Type 1. I'm sure that's right. Probability of type 2 and 0.5 or 5%.
0.05 is what I'm going to put.
Okay, I'll put it too. Ready?
Yep. 95. We missed one.
Okay.
We missed, the sample statistic in this lesson is Z.
Ah.
I don't think, yeah, it is. It is. Because I remember this now because it says it in here even. It says on part 5, it says, compute a test statistic. What formula is to be used? Recall that in this lesson, a sample statistic will be the Z-score.
Oh.
I forgot about that.
I didn't even remember reading that. So that's on what part?
If you go into your prep and it's on question IV under number 2.
Oh. And then number 2, on the second part of the first part.
The second part.
IV.
Yeah, so it says the National Association of Realtors, and then it says compute the test statistic.
Design a study, calculate, describe, refer, state null, compute.
Oh, maybe
Okay.
it's, yeah.
The formula is used. Recall test statistic will be Z. Ah! Okay.
Yeah, that's okay. We still got a 95.
Statistic in this lesson is Z. That was a trick
Z.
question.
Yeah, that was a good one. I remember
Okay.
that now, though. Okay, sounds good. Remember to go and post that you were at this video. Do you know how to do that?
Yeah, I do.
Okay, sounds good.
Okay, thanks.
Yep, see ya.
Yeah.